All right, we're going to get started. So, this is an overview of mining and metallurgy in period times, primarily from a European or Middle East to European perspective. It's a really big topic. I wanted to do a more world inclusive bit, but there's so much information, I wouldn't have been able to get it all into one class, even on introductory level. So, I went this way, but I'm going to do some other classes later on with other cultures in mind. I'm specifically going to do one about jade, I think, at some point. But anyway, all right. So this is my fair use slide, and basically says, hey, I'm not making any money off of this. So, hopefully I won't get in trouble. On the top right there, you've got some sedimentary hematite, and that is iron ore. On the left, you've got an illustration from a very late period work. I want to say this is from maybe one of Gessner's works, but I can't remember. Definitions. So we have some definitions here. Metals are metal ore, iron, gold, copper, zinc, silver, lead, antimony, etc. Industrial ores are clay, abrasives, flint, obsidian, salt, sal ammoniac, and filtrants like diatomaceous earth. So this class is going to be on metal ores. On the left there, we've got an actually very old salt mine in Salzburg, Austria. On the right, stained glass in Yorkshire showing a gentleman mining. And this is probably pretty old stained glass here. I'm going to guess like 1200s, 1300s maybe. Scope of the class. So this is a quick overview of a very deep subject, pun intended. The class focuses on mining and the related extraction metallurgy in medieval Europe and connected areas to around 1600 in the Common Era. So we're going to dig in and have some fun. On the right there, you've got a 16th century German mine illustration, 1690. So that's a little bit after our time, but it's very similar to what they would have been doing. And if you can look, you see the little lines in the shafts and stopes there. Those are logs. So they were lining them with logs. They sort of understood how to keep the ceilings propped up, but they didn't always do that great of a job. And well, we know what happens when that happens. People get hurt. Some older background, ancient Greece. So if you've heard of the Golden Fleece, the story has a basis in fact. Sheep fleeces were used in ancient Greece to catch stream gold, as the mechanical and surfactant properties were perfect for catching fine gold in a sluice. The fleece would then be dried and beaten over a cloth so the gold dust would fall out. So the golden fleece actually refers to alluvial gold mining techniques in ancient Greece. The ancient Greeks were talented miners. Unfortunately, they relied a lot on slave labor aside from the overseers and quote unquote natural philosophers that understood the ores. Life for a captured miner was brutish and short. Famous sites included Lavrion or Lorient, which is famous for silver and lead, Cyprus, named after copper, Cyprium, and modern day Lydia, Turkey, that produced gold. The mines at Lavrion are famous to this day and are still being actively explored by modern Greek researchers. This particular set of mines in Attica made them a major power in the area because those mines, yeah, they were producing, gold for sure, but also silver, lead, zinc, and other things. On the top right there, we've got an old entrance to a silver mine at Lavrion. So this mine probably dates to the actual Greek era, although you can see there's a pipe up top, so it's been worked some in modern times too. We have Jason and the Fleece from a crater around 340 BC there on the right, bottom right. Some older background, the Romans. So the Romans were very well versed in mining technology. They knew how to control the people they had conquered and exploit local mineral resources, and they also performed mine engineering. They advanced it more than the Greeks, for sure. As with the Greeks, much of the mining done in the Roman Empire was done by, unfortunately, enslaved people. Obviously, they were after the usual suspects: gold, silver, lead, copper, tin, iron, clay, and such. The Romans were notorious for their use of lead and other toxic metals in public life. Lead pipes, lead makeup, lead weights, lead wine sweetener, lead hair wash. In fact, the current symbol for lead on our periodic table, Pb, comes from the Latin word for lead, plumbum, which is where you get plumber and plumb bob and plumb crazy, all related to that Latin word. They were known to smelt lead by building furnaces tended by slaves on the top of windy hills. They would cut holes into the hill and set the smelter up to be wind fired and fed by the local wood. Of course, the contamination killed the surrounding vegetation, the slaves, and poisoned the soil, and probably the people that used the stuff that they made. So on the top right, you've got actual Roman era lead pipes from London or Londinium. Those were found during excavations. And then on the bottom right, you've got the funnel for a Roman iron smelter. So the iron would have been coming out of the left-hand side of that tube, and probably there would have been some sort of way to feed it from up in the top. Viking silver connection. So the Vikings are very well known to have a love of silver. They mined some, looted more, and much of what they worked with came from Europe and the Middle East via trade. They were known to melt down coinage, items, and jewelry from other pieces, and this included hack silver, which are pieces of cut-apart silver items used as money by weight. And on the top right there, that's a picture of a lot of hack silver from a hoard that was found in England. It's very interesting that modern X-ray fluorescence studies of these items often point to distant mine sources. These include Iraq, Greece, and Turkey, and there are famous silver mines at Kongsberg in Norway also, but those didn't really come online until the very end of our period times. Most of the silver that the Vikings were messing around with came from somewhere else. And I've just read a paper recently, within the last month or two, where they've completed an isotopic study that showed that a lot of what they were seeing came from England, Cornwall, and Turkey. So I happen to be a metallurgist professionally. Well, chemist, but anyway, I work in a metallurgy lab. And I had the honor of being gifted an actual Viking era silver ingot, a piece of hack silver, and that's a picture of it on the top right there. So I was curious to know what the composition was, so I shot it with X-ray fluorescence. And this is the same method that archaeologists are using to determine the origin of metal artifacts. So on the right there, you can see it's about 87, almost 88% silver. But there are other things in it: copper, zinc, iron, chromium, nickel, which is pretty weird, a little bit of lead, a little bit of gold, 0.6%, and a few other things. And, the mix of elements probably reflects that they were melting and using whatever they had to make that particular ingot. The gold was a real surprise. I wasn't expecting to see that. The lead, I'm not surprised about at all because it's pretty much in everything from back then. But anyway, European Middle Ages. So mining in these times was generally focused on just a few things: iron, copper, tin, and lead. Industrial production would have been focused on these. Iron was needed for iron and steel, copper and tin for bronze, and lead for a whole lot of other things. Miners were generally farmers in the off season in Europe. Convicts and the rare person of knowledge also worked. Of course, the enslaved were still doing the worst work, but in these times, farmers and such would do some work in the off harvest season, and things change, especially if ore strikes worked out. They might end up doing it full on. Around the 14th century, there was a highly increased demand for iron to be converted into steel, not just for weaponry and armor, but also for other uses, tools, things like that. So here on the left, we have an iron bloomery smelt illustrated from the Middle Ages, and I'm pretty sure this is from Birunguccio. We'll get to that later. But they're feeding the ore in at the top, then the molten iron is coming out the bottom. And you can see some tools and tongs and things there to manipulate the ore and rocks and things like that. Probably a very nasty, dirty, and stinky operation, I'm sure. I've got a friend here in Atlanta, or well, I'm not in Atlanta anymore. I've got a friend in Atlanta, Sir Mark, and he actually does do his own iron smelts with ore that he's collected himself. It's pretty cool. Like actually makes swords out of it. All right, Italian Renaissance. The Pyrotechnica of Vannoccio Birunguccio was a masterwork. This book laid out all the steps needed to find, work, and refine various ores. This was a major step forward in mining and metallurgy, and this came out in the early 1500s. Gunpowder pots from the Pyrotechnica. So at this point, he was describing gunpowder. And if you look over there on the left, you can see those barbed arrows. They've got gunpowder bags hanging off of them. Maybe they're arbalest bolts or something like that. Now, in the course of my research, I realized that he got this information somehow through Chinese sources because the Chinese had very extensive gunpowder operations at this time. They had rockets and everything. It was pretty wild. But that's another class. De la Pyrotechnica by Vannocchio Biringuccio. So, among the highly skilled craftsmen of the Italian Renaissance were those who worked with ores and metals. And Biringuccio can kind of be thought of as the father of modern metallurgical science. This man was a mining and metallurgical genius. He gives us a very accurate accounting of the measurement of the strike and dip or orientation of vein formations. The Pyrotechnica mentions red earth as an indicator of the presence of iron ore at a site, and varying descriptions of different types of iron ore, their appearance, and their suitability for refinement are recorded in the book as well. De Re Metallica, which is where the name of the famous band came from. In 1556, Georgius Agricola wrote a book in regards to medieval mining and metallurgy called De Re Metallica. His knowledge is amazing. He's considered to be a father of mineralogy. Sadly, most boots on the ground miners in his day were still in a pretty inhumane pickle. Mining is kind of inherently dangerous. So this book contained a thorough treatment of mine engineering, woodcuts, illustrations of mining methods. It was one of the first books to actually put all of that in one place for other people who were interested in operating or doing a mine. The life of a miner was also described thusly by him. Mining is a perilous operation to pursue because the miners are often killed by the pestilential air they breathe. Sometimes their lungs rot away. Sometimes the men perish by being crushed by masses of rock or falling from ladders. And on the left, that's an illustration from De Re Metallica. That's some type of a smelting furnace, undoubtedly. The channel on the front that has that kind of droopy looking stuff come out of it, that's probably metal. And you got a gentleman with some sort of stirring rod there, or maybe he's taking a sample. So this is a map of metal production in the ancient Middle East, and these are the metals commonly mined, alloyed, seen, and looked for. You can see that Egypt was producing some gold. There's definitely gold coming out of Turkey. A lot of copper coming from Cyprus because, well, Cyprus is named after the word for copper. And you can actually see some gold coming out of India down there on the bottom right also, which is very interesting. There was a big connection with precious metals and gems coming out of India and making their way into Europe. Local mining. So many folks were farmers that mined on a small scale in the off season. And so basically got stuff around, hey, let's dig it up and hope the nobles are okay. But usually the wealthy would take productive mines for themselves, then the nobility would take it from them, the king would take it from them, and so on. The most popular way to obtain gold historically was to take it from someone else. So here on the right side at the bottom, we have a medieval tin ore mine shaft in Cornwall. Wouldn't want to fall in that. And then we have a mine illustration from Agricola next to that. And you can see he's got, illustrations of shafts and it looks like a head here to raise ore buckets and things like that. You can see a little guy with a cart there in the middle to the left. So you're looking at middle 1500s, I think 1550, 1560 or something like that when that book was written. All right, gold, the one metal everyone wants. Gold is malleable, easy to work, and does not corrode. So many ancient and period cultures sought this metal, fought, and died for it. Gold was mined in several places in antiquity in the scope of this presentation. So Ireland, Turkey, Wales, Greece, Sudan, Egypt, India, and others. So the second on the right gold nugget there is from Fluvanna County, Virginia. A friend of mine found that and actually analyzed it, and it ended up being about 90, I think it was 93% gold, about 3% silver, and then the other 4% was other stuff. But those are a couple of native gold specimens with a penny for size that I've got in my collection. Over here on the bottom left, you've got an actual gold vein. It looks like it's probably in quartzite or something like that. That gold there has different colors, so it's probably mixed in with some sulfides and thing. I don't think that's pure gold. And then the alchemical symbol for gold there is also the symbol for the sun. Copper ores. Copper ores from various locations. Copper usually presents as green or blue stains in the rocks and was mentioned by Pliny the Elder as such. Pliny the Elder died in 79 AD when Vesuvius erupted. Copper was an extremely valuable metal for period societies. A lot of copper in antiquity came from Cyprus, which was named after the metal, and is critical for bronze and brass, among many other uses. So you got a native copper nugget down there on the bottom. On the top right, you've got some copper ores and copper specimens that are in my collection. You can see they look a little different. Some of them are kind of brown or metallic looking like you'd expect, but then you've got some malachite over there on the far right, and that's like a copper carbonate. In the middle, it's the symbol for Venus, which is also the symbol for copper. Silver ores. Silver was also highly valued. Indeed, to the Egyptians, it was more valuable than gold as it was harder to refine and more scarce. There are recorded instances of silver staples being used to close wounds by the Romans. It is antibacterial in nature, so this makes sense. On the bottom left there, you've got some wire-type native silver. That's probably from the Königsberg mine in Norway. It's a pretty fantastic specimen. On the right, you've got some of the silver specimens that I've got in my collection. There's some native silver from Michigan there on the top right. There's some Mexican silver. I think there's some silver from Ontario and a few other places. Don't have one from Norway yet, but I'm working on it. The symbol for silver, alchemically, one of them was the moon. Tin ore. So originally, when I wrote this class, it was based in Atlantia, so that's why it mentions that. But cassiterite is very uncommon in Atlantia, and in fact, it's pretty uncommon in the US in general. It was found historically in Cornwall, Turkey, Greece, and other areas. Tin is critical for bronze production. That is a chunk of tin oxide there, cassiterite on the right. Now, interestingly, I also read I would say a month ago, a paper where they finished some isotope studies on bronzes from different places all over Europe, and almost all of it was mined in Cornwall. The tin that was in it came from Cornwall, and they can tell this by the trace element isotopes that are in the metal. Very interesting. I mean, they found bronze that has tin from Cornwall in it, like in Persia, in Ukraine. So very interesting. Lead ore. Lead ore, galena and cerussite, which is lead sulfide and lead carbonate, were found in England, Greece, Morocco, Spain, France, and Ireland. The Romans were big fans of lead, and as we already talked about, their smelters are toxic waste sites that poison the land and water, and in fact, some of them remain that way to this day. On the bottom left, you've got some galena, so that's lead sulfide. And on the right, you've got lead smelting, and you see all those nice little vapors coming up out of there that those guys are breathing. I'm sure that's just absolutely great for them. If you were one of the slaves that had to run a lead smelter in Roman times, your life expectancy was months, even if you were perfectly healthy when you started. The symbol there is a symbol for, let's see, Saturn, which is also the symbol for lead. Antimony ore. Stibnite, which is antimony sulfide, was the most common ore of antimony. It's a soft, lustrous, and flaky mineral, a lot like graphite. It is often associated with volcanism and is abundant in Italy. The mineral was used as coal eyeshadow, and it's very toxic. It was also used as a bronze and lead additive. Now, unfortunately, back then, a lot of cosmetics that women mostly, but also men were using were extremely toxic, like lead face paint, antimony eyeshadow. I mean, your body was like a walking toxic waste zone if you were a rich person wearing this stuff. Here we've got an image. This one, I believe, is from a Roman era coffin from Alexandria, but this lady probably had some antimony eyeshadow in her eyebrows there. On the right, you've got a stibnite crystal, so that's antimony sulfide in its native state. And I think that one is probably from China somewhere. Iron. Iron as a metal was important to European society during the early scientific revolution and in general. The metal had many uses, including as tools, implements of warfare, architecture, and more. The knowledge at the time of iron ores, mining, smelting, chemistry, and even crystallography were surprisingly advanced. The chemical properties of iron began to be cataloged and studied in earnest at this time. Flame test assays of iron are mentioned by Agricola and Birraguccio both, and so a blue-colored flame and an infernal odor to test for sulfur was mentioned. So they would take a little piece of this iron and burn it in a really hot flame, and if it stank like sulfur and burned a little blue, then it had sulfur in the metal, and that causes problems if you're trying to work it. It makes it want to crack. It's called being hot short. So iron ore with a lot of sulfur in it really wasn't very good for a lot. Certainly not for weapons or making steel. On the bottom right, you've got some hematite, that is iron oxide in its native form. You've got there on the top right an iron smelter. This is probably later period. You know, each one of these little items has got a letter by it. So if you were looking at the actual text, the letter would tell you, you know, what each piece was. And that was a first. Nobody had done that before either. And then the symbol for Mars is iron. Mercury or cinnabar, mercury sulfide, was mined in Italy, Slovakia, India, China, and other places. It was used extensively by alchemists for gilding, for fabric treatments, and in quote-unquote medicine. Chinese alchemists were obsessed with ingesting it with predictable results. They died. In fact, the Yellow Emperor supposedly died from ingesting cinnabar as he attempted to find a method of eternal life. Gonna probably do a class on Chinese alchemy at some point too, but I'm not there yet. Raw mercury metal was considered a miraculous substance as it was the only metal which was liquid at room temperature. It's used in many ways, such as gold amalgamation, gilding, hat making, pigments, and others. And if you've heard the term mad as a hatter, you know, the amount of mercury that was used in the hat making was what would drive people mad wearing those hats because they're absorbing it. On the bottom right, you've got some cinnabar, which is mercury sulfide in its native state. You've got some liquid metal mercury there. And of course, the symbol for mercury is mercury. An oddity, uranium. Believe it or not, uranium ore or pitchblende was being used as a colorant for glass by the Romans and later in medieval times. The use of uranium glass has been documented as far back as 79 AD. A mosaic containing yellow glass with about 1% uranium was found in a Roman villa in Cape Precipio outside of Naples in 1912. Probably destroyed when Vesuvius erupted. There's that 79 AD date again. In Czechoslovakia, pitchblende from the silver mines at Joachimsthal was used as a glass colorant in medieval times. And here on the right, we have some pitchblende ore or uranium oxide. And it looks a lot like the hematite, but it's really, really dense. I've got a couple pieces in my collection, and it is quite radioactive. Now, obviously, the Romans didn't know that, and neither did the medieval people. But what they did know is that people that worked in those silver mines at Joachimsthal in Czechoslovakia tended to die from lung cancer or, you know, rot of the lungs, however they would have called it. And that's probably from inhaling radon gas and uranium dust. Okay, that brings us to the end. I hope you've enjoyed this presentation. There's a lot more to this topic, and hopefully the small overview will whet your interest in the body of lore. Thanks to everyone that taught me and inspired me to teach, and also to my helpers, Jet and Sage.